Okay, in this video, we're going to talk about some of the special properties of water that are important to life. So let's first talk about water. So water is a covalent compound, which means it shares electrons, but it shares them in an uneven way. The electrons spend more time around the oxygen than they do around the hydrogen, and creates polarity, or areas that are slightly negative around the oxygen end and slightly positive around the hydrogen ends of the water molecule. You can see the negative and the positive ends here. So this allows for something called hydrogen bonding to form, which is an attraction between the hydrogen atoms of partially positive charge and another atom with a partial negative charge. In this case, we're looking at water molecules attracted to each other, but they could be attracted to other things as well. So one of the properties that's due to hydrogen bonding is called cohesion, where water molecules stick to each other. And in the picture here, you can see the skin of the water allows the water strider to walk on the water. Another property is adhesion, where the water molecules stick to each other. That allows the water to move up little tubes like you see in the picture here. This is important for getting water up through the tubes in the roots of a plant up towards the leaves. The smaller the tube, the further up the water molecule goes, and when you look at a water in a tube, you see that the surface is not straight across. It has a little curve. We call that the meniscus. Heat capacity is important too. Heat capacity is the amount of energy needed to raise the substance's temperature by making its molecules move faster. Heat is a measure of how fast the molecules are moving. Water has a high heat capacity, which means that it takes a lot of energy to change the temperature of water. And this helps keep the environments stable, helps keep our body temperature stable since we're mostly water. There's also, when we talk about water and its ability to dissolve things, we talk about different kinds of mixtures. A mixture is not a chemical compound. A mixture is when materials of two or more elements are mixed together, but not chemically combined. Like mud is a mixture of water and dirt. A solution is a mixture in which the solute, the substance that's being dissolved, is dissolved in the solvent, the substance that does the dissolving, like when you make lemonade. A suspension is a mixture of water and non-dissolved materials. If you shake up something in a suspension, eventually some of the particles will settle down and they'll separate out. So water's polarity gives it the ability to dissolve both ionic compounds and other polar molecules. So it's a really good solvent. Lots of things can dissolve in water, and that's important because it allows water to be a good transport medium, carries a lot of things through the bodies of living things. The next thing I want to talk a little bit about are acids and bases and pH. So pH is a scale from 0 to 14 that indicates the concentration of hydrogen ions in the solution. An acid is any compound that releases hydrogen ions, so it's going to raise the concentration, but it actually lowers the pH. The more acidic something is, the lower the pH is going to be. A base is a compound that produces hydrogen ions in solution, or hydroxide ions, in a solution, or absorbs hydrogen ions. So it's going to be higher on the pH scale. So 7 is neutral. 7 is pure water, where the hydrogen ion, the hydroxide ion, which is water, are equal. If you get below that, it becomes an acid. Above that, it's a base. Our blood is slightly basic, about 7.35. Bleach, on the other hand, is very basic. Juice from fruits is often very acidic. Stomach acid is very, very low on the pH scale. Toothpaste, you can see, slightly basic. So living things have these things called buffers that help maintain homeostasis. They are weak acids or bases that can react with strong acids and bases and prevent changes in the pH. They keep the pH of the living thing where it should be.